its activities or its measurement of mass, abundances, and the detection of what? Of isotopes. Then a diagram of mass spectrometer must be used. So for you to understand how the principle of working of mass spectrometer is not enough. It's tough, first of all, to learn by reading those descriptions or those explanations. The best way, we have to draw a diagram of mass spectrometer, and then we explain its principle and how does it work. Okay? So join me in the sketch of this mass spectrometer. I'll be trying myself, but you can even look online. You can use the references online or in different sources to see even in color. For me, just a bit draw by using the black and white. For you, you can even refer the colored spectrometer. Okay. You can also go to your school lab and ask your teacher to show you the mass spectrometer. It's your right. Okay? So again, here we have a plate, and here again we have another plate. Here we have this is accelerating part. Okay? We'll explain what does it mean. And then from this point, we have a very important part, which we call the deflection region. So here we have a heating filament. Filament. And then this point, you have vacuum pump, a spectrometry routine at this point. Then we have again another part here. Then we have the output at this point. It goes to another section. And then the output of this section, and this one we call the amplifier. This goes to another section. We call it the chart recorder. Very important part. This is the recording section. So this point, called deflection. And then this one, called the vacuum pump. Vacuum pump. This section You can even share. So it has a shadow. So this section, when you say this section, both this and this, we call that section is deflection. Deflection region. But what does it do, this deflection? This is a magnet. And this section, this one, this ray, we call it the acceleration section. This is part 2, the second part that I have mentioned there, acceleration. And then this section, this point here, this one, this we call it ionization. Ionization chamber. Here we have another part we call it vaporize the sample. Vaporize the sample. Then this one we call it heat source, or source of heat. Source of heat. So that one's vaporize sample. Here's to vacuum. And then this is figure 1. We call it mass. Mass spectrometer. You can call it even figure 1.1 because we're having many figures. So figure 1.1. We have 1.2, 1.3, etc., etc. So my dear student, my beloved student, that is a diagram of what? Mass spectrometer in chemistry. Let's draw it on your hand. Don't take a photo. You have to use your own hands to draw it, like the way I drew it myself. I can use the digital technology. I could take even the photo and show you in place at in front of the camera, and then show that this is a mass spectrometer. And then you'll enjoy and you'll say that, thank you, Sir Olenjolai, but I didn't help you because you didn't see that how you can draw it yourself. So from now you don't have an excuse. If you'll be asked to draw it, you have to draw it. You're a chemist, so you have to like draw it. So this is the figure now of mass spectrometer. One, let me explain to you how does it work, and then we'll go to the details, explanations, or on learning those 5 parts. Okay? Listen carefully. This is the mass spectrometer, and this is the inner part of mass spectrometer, right? Physically, it doesn't mean that we'll find a device, mass spectrometer like this. This is the inner part, and especially that we used to learn the operation part, right? The chemical or the chemistry operation part. There are some other parts. It can be maybe electrical mass spectrometer or some other spectrometers, right? So what happens? This is the point of influence. Here we have vaporized the sample. What the means of vaporization? Vaporization, we say that is what? Is a physical change. Why not? We say that liquid, or is that maybe you change solidly to liquid, liquid to gas. So the destination is forming gas, right? So the sample, which you want to measure its mass, you want to determine the number of isotopes of that sample of the atom, and you want to determine its abundance. Is introduced at this entrance point. That's why we call this one vaporize the sample. Then the vaporized sample, as soon as it has been introduced in the mass spectrometer, it will reach the first sections or the first chamber called the ionization chamber. So in the ionization chamber, remember that this is an atom. What's going to happen here? And then a lot of things will happen, but in brief, in this ionization chamber, the vaporized sample is going to be given ionization energy, If the sample has to lose 1 electron, then it will be given as the first ionization energy, as well as I will teach you in energetics or in chemochemistry. If the atom is going to lose, or it has a tendency of losing 3 electrons, right? Losing 3 electrons, or 2, for example, for aluminiums, then it will be given, at this point, it will be given first ionization energy, second ionization energy, and third ionization energy. But if the atom is just sodium, then we need only first ionization energy. If the atom is magnesium, which is period 2, period 3, which actually is 12 elements in the periodic table, then we have to give it the first ionization energy, second ionization energy. So that's the main function of this chamber. After the atom has been ionized, so now we don't have atom anymore, we have an ion. Say an ion. So not an ion, the one that we used to maybe we use in domestic. I don't mean about that. Iron, because sometimes pronunciation is a little challenge. I'm not talking about this iron. No, I'm talking about this iron, right? So we have an ion. So what happens? So this ion is still moving or traveling with a very low speed. So what happens? So in mass spectrometer, we need these ions to be accelerated, to move. It means to move with a very high speed. So what happens? So we as the chemists, we're against that we make another chamber known as acceleration chamber. So the main function of acceleration chamber is to accelerate an ion which has been ionized in ionization chamber, right? So when you accelerated, that ion now will reach to this point, to this part, which is called deflection point, and this we call the deflection field in some of the books. Okay, we call deflections, or we call it deflection field in some of the deflection field. So be familiar about that. Then when it reaches a deflection field, what happening here? Remember that at this point now, because now it means that this sample has been vaporized at this point. So these dotted lines is the trajectory, say trajectory of 40 of this vaporized atom, and then at this point now we see the isotopes now of 40 of atom. Okay, so this now it has been moving linearly. So remember that this atom, it has been moving linearly in a straight line. So when it reaches in this radius of 40, you can even just add this magnetic field, you can extend it, okay, so that you can understand the concept, okay? So when it reaches at this point, what happens? This magnetic field, this magnet, so magnet 1, magnet 2, these are the magnets. So when it reaches at this point, then these magnets will start deflecting. Instead of, because remember here, if we consider the trajectories are the vector, this the vector, means these the directions of what of electrons. So it reaches here because this ion is actually is electric charge, or is electrical ions. It will be deflected by this magnet. When it will be deflected now, remember that it is highly accelerated elements, then it reaches at this point and then start forming isotopes. So for this element, for example, if you have first line, second line, third lines, it means there are 3 isotopes. So here it determines isotopes, it determines abundance, then it determines its atomic mass. So again, the journey continues, reach at this point at the vacuum pump, also it has something else to add on that, and then now the ions reaches to the deflection, so detection. Sorry, this is not deflection, make correction please. I wrote, you could even ask me, this is detection unit, right? So correct it please. Yes, detection unit. So then here we detect the number of isotopes, we detect the abundance, we detect the mass of an atom, and then we'll see how does it operate, because we have computations, we have mathematical, and we have problems. And then the output of this sample, so this is still the output of detection region or detection unit will be sent to the amplifier. Say amplifier. Amplifier is very important part in analog electronics. I like electronics a lot. I'm an electronics engineer, as I can tell you. I used to learn a lot about amplifier, and they are doing a big business actually that in the world of electronics of today. So here it means that the ions will be amplified. Means that what the means of amplification? It means that changing its magnitude from the small magnitude to the large magnitude by using what the amplification factor, which we call total gain. It might be current gains or voltage gain. And then here we have total recorder. So this is the recording sections, because we say recording section, the last part. So here the point that we used to record, and here this is the point where we used to find out a display which will be showing the lines of the isotopes which will lens in near future. And then that's how now we have that's how the mass spectrometer measure, or that's how the mass spectrometer operate. Okay? So in the next few minutes I will be explaining this part, how does it work, this part, and even this part. So I've just given you an introduction. I'll be explaining and writing some sentences for you to review them. So after we've discussed this, remember that one thing that I want to tell you, and even myself I find when I was in high school 11 years ago or 12 years ago, this is the common question for the midterm test for those pre-form 5, and even the final exam in some of the years I used to give you 10 marks to draw this and explain how does it work. So take care about this. You might remember me maybe one day within a specific time when you are in hot chamber of exam. Then another part that we have to cover, we want to learn in brief principles of mass spectrometer. Principles of mass spectrometer. What are the principles of mass spectrometer? We have 5 principles. So the question is, this is maybe question 3. Yeah. Describe briefly 5 principles of mass spectrometer. The first principle is this. We say that the substance, it means atom, not ion, the substance to be analyzed. Substance to be analyzed is firstly vaporized. It's firstly vaporized, right? And it is then it is introduced in the ionization chamber. The ionization chamber, where a metal filament is heated strongly to produce enough energy to cause ionization. Cause ionization to occur. occur, that is positive ions, are formed. The first principle states that the substance, for example, magnesium, aluminium, sodium, lithium, right, carbon, the substance to be analyzed, that we want to analyze, we want to measure its atomic mass, we want to detect the number of isotopes, we want again to know its abundance, is first vaporized. What the means of vaporization, as I told you, if it is in solid state, vaporization reactions with the given atomization energy will be given to that metal, and then to be changed from the solid state to the gaseous state. So what we used to introduce the mass spectrometer should be in gaseous state. Remember that. And then it is introduced into the ionization chamber. So this the ionization chamber, as I told you, ionization chamber. So then where a metal filament, so this is very important again, a metal filament, where the metal filament, this one, this is metal filament. A metal filament is heated strongly. So this metal filament is heated strongly. So we have a filament here. Okay, we have a filament. So metal filament is this one. Is heated strongly, right? It's heated strongly. Metal filament is heated strongly. Metal filament is heated strongly to produce what? Enough energy to cause what? Ionization to occur, and that is the positive ions are formed. So we used to form positive what? Ions. Means electrons. Ionization means that it is a process whereby an electrons, or whereby 1 mole of an atom is what? 1 mole of an atom is losing 1 electrons to form what? 1 mole of what? Mono positive ion, if it's first ionization energy. But from 1 atom of what? 1 atom of positive ion. No, 1 mole of positive ion. By the means of what? Ionization energy. The second principle is this. The positive ion ions produced in the ionization chamber. Ionization chamber are accelerated now by the negatively charged particle, negatively charged plates. So the positive ions produced in the ionization chamber accelerated by the negatively charged plates. Where are the negative charged plates? This one. Okay? So these are the negatively, so this is negatively charged. So this is negative, negative, negative. This is also negative, negative, negative. Charged what? Particles. Okay. So the third principle, we said that the positive ions produced then deflected. So we say about accelerated, it's better if you bold it. So let us bold this way the acceleration or accelerated. So here are deflected. 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 Okay? Are deflected by the magnetic field. By the magnetic field according to the so remember that these are the principles of working. Principles of working of mass spectrometer. You see it? Let me just write it clearly. That's very important to read. This is how the mass spectrometer works. Principles of working of mass spectrometer. So describe briefly 5 principles of working. 5 working principles. 5 working principles of mass spectrometer. Or sometimes in some of the books, how, you can ask you a question, how does mass spectrometer work? Explain how does mass spectrometer work. So this is the description. So the positive ions from the acceleration chamber produced are then deflected. By the magnetic field. By the magnetic field according to the mass. These deflections depends on what according to the mass. Okay, mass to charge ratio. Mass to charge ratio. Mass to charge ratio means mass over Z. Such that ions with greater value of ratio are deflected less. I don't want to rub here. Please make sure that you copy that section. I want to leave this because I want to use it for explanation. But let me just explain this the principle. The positive ions from what? Acceleration chamber, where we have negative plates, are deflected by the magnetic field here. This is the positive ions deflected by the magnetic field according to the mass to charge ratio. Mass to charge ratio. So this is the point where it has the mass to charge ratio. So listen, what happened? An isotope which will have a large mass, a large ratio of mass to charge ratio will be less deflected, right?